All right, guys, looking at 10.7 here. 10.7, our last section of chapter 10, talks about circles in the coordinate plane. So we've dealt a lot with circles. We've done everything with circles so far. We haven't really dealt with them in terms of graphing or equations of, and that's what this is about. So our basic equation of a circle, our standard equation of a circle, we see it here. We see x minus h squared plus y minus k squared equals r squared. And h comma k is going to be the center of the circle. Okay, h comma k, center of the circle. Notice that our equation is x minus that, so it's going to be the opposite of what you see. And we've seen this before in algebra and geometry. It's the opposite of what you see there. So if it's x minus 3, that means our h value is a positive 3. If it's y plus 4, then k is a negative 4. It's the opposite of what you see in that equation. And then r, of course, is the radius, so radius squared. Basically what this is, guys, this is Pythagorean theorem. Right? You look at the picture over here, it is Pythagorean theorem. We're talking about the distance between the point on the circle. So xy is just any point on the circle. Right? So we're looking at the horizontal distance between the point on the circle and the center of the circle, x minus h. We're looking at the vertical change between the point on the circle and the center, so y minus k. So we've got this squared plus this squared equals radius squared. It is Pythagorean theorem, right? Or distance formula. We know there's a great relationship between Pythagorean theorem and distance formula. But it's the same thing. So this is our standard equation of a circle. That's what it's going to look like. If you don't see a plus h, you just see x squared, that means h is 0, right? You see you don't have a k, that's k is 0. So if you just have x squared plus y squared equals 16, you know the radius is 4, and then the center is at 0, 0. It's going to be in the middle of it, right? So not a whole lot of what we're going to do. They're going to ask you to write the equation for the circle. So here we've got our radius, our center of the circle is 0, 0, and then the radius we can count as 3. So if the radius is 3, the center is at the origin, you plug in your zeros, you get your radius of 3, we got x squared plus y squared equals 9, and that's it. If you've got a radius of 4.2, you got to square that on the right side, and our center is 0, negative 9, so that's x minus 0, y minus a negative 9, so remember it's the opposite of what you see, so it's a y plus 9 there. So that would be our standard equation. We're not going to FOIL it. We're not going to simplify it at all. It's going to stay just like that. That is the equation, right? So when we see, right, stuff like that, we can write out the equation. And then the other type of situation they're going to give, they're not going to give you the radius. They're going to give you a point on the circle. They're going to give you the center of the circle. Well, that's enough to find the radius, right? The radius is just the distance from the center of the circle to any point on the circle. So if you want to find the radius, you just have to do distance formula or Pythagorean theorem if you want to draw out the triangle. But you know, they don't give you a graph here in this. This graph is part of their solution. This is just the question. So they're not graphing. We don't have to graph it. We can solve it just by looking at here. We've got the point, we've got the center. Use distance formula to find the radius. If we use distance formula to find the radius is going to be 5. And so now that we have that, we use the center and the radius. The center is the negative 1, 3. The radius is 5, so that's going to be x plus 1 squared plus y minus 3 squared equals 25, which is that radius squared. So you got to use distance formula to find that radius, and then we can do it from there. That's the majority of what this section is, guys, is just those two examples. Being able to create the equation, whether they give you the center and the radius, whether they give you the center and a point on the circle, we got to be able to solve that. Now, example 3, graphing the circle. This goes into what is called completing the square, and I mentioned that in the notes for this week. We didn't learn completing the square. The high school teachers have told us we don't have to teach that, so that is something you will learn in Algebra 2 next year, completing the square. So I didn't put on the assignment on Big Ideas, I didn't put any questions that asked you to complete the square on there. So really what this is going to look like in terms of us, let me pull up my screen so I can write on it here. What it's going to look like for us is you're going to be given an equation, right? Maybe that equation is x minus 2 squared plus y plus 1 squared equals 16. Let's say we have that equation. They're going to be asked to graph it. You are going to be asked to graph it. They have a way of graphing on big ideas. But let's say that we need to graph it. We know the center of the circle. The center of the circle, the opposite of what we see. So the center is 2, negative 1. That's the center of the circle. We know our radius, this is r squared. So if we take the square root of it, our radius is going to be 4. So when we go to graph, all we have to do is plot that center. So 2, negative 1. There's the center of our circle. If the radius is 4, all I want you to do is I want you to go 4 in each direction. So it's down 1, 2, 3, 4. There's a point. Up 1, 2, 3, 4. There's a point. To the left 1, 2, 3, 4. There's a point. To the right 1, 2, 3, 4. There's a point. And then just sketch it out. Okay, it's the least accurate graph that we do in algebra and geometry, but that's all you have to do. Plot the center, use your radius, go 4, in this case 4 in every direction, get your 4 points, and then sketch a circle around it. And that's all we have to do to be able to graph it. So the graphing ones that you're going to see on the assignment are going to be like this. It's going to be very straightforward to be able to graph it. You don't have to do that completing the square at all. So really that is it for this 10-7. It's a pretty quick one. We really only did 3 examples. There's more stuff in here, right? Write a coordinate proof. Yeah, I know you don't want to do that. We're not going to do that. You got real life problems. You might see something like that. Nothing like this. Nothing to this extent. This is pretty intense here, trying to figure out. But it's interesting if you're interested in it. It's talking about how to find where an earthquake occurred. So that is, actual real life stuff. So if you're interested, read through it, see what they did to be able to find that. Other than that, that's it for 10-7. Okay, and that's it for chapter 10. There you go.